First of all, I apologize for my voice not being up to... I have a flu, and I did a training course on microservices in Rome yesterday, so I was talking for the whole day, which means my voice now is breaking a bit. So I hope it will stick for the next 40 or 50 minutes or whatever time we need to do this. This is a talk about microservices. It's probably not the first one you've seen. It is one of the big buzzwords right now. It is one of the hypes that we actually try to follow or not. And I've been busy with this stuff for, let's say, the last 30 months. It's slightly more, but 30 is okay. It's a good round-off. And there isn't much more you could have done with it because it's a fairly new technology, right? So there is no set of practices, guidelines that you can follow and say, okay, you know what? We're going to implement this thing tomorrow and then we'll be done next week. So you have to figure out a whole lot of stuff, which is, as a developer, which I am, is a good thing, right? Because you can figure out all new stuff and try to make it work and stuff. That's what we like as being developers, right? So that's what this talk will be about, basically what we've done for the past 30 months without being bored. Anyway, so this is me. This is a name unpronounceable in Italian, I guess. It's unpronounceable in any other language than Dutch. I'm Dutch. And my name is in Dutch. I'll spell it in Dutch for you. It's Sander Hoogendoorn. You don't do that in Italy, right? So I'm basically an independent consultant. I've been there for the last year and a half or so. Before that, I worked for large companies like Capgemini and stuff like that. And but basically, I'm a dad. I have 3 kids of my own. The oldest one is living in Budapest. The other ones still live at home. My girlfriend has 2 more. So we're a busy crowd. And in my spare time, I write code and I do software architecture. And I do agile coaching, stuff like that. My website is up here if you feel the need to look at it. There's lots more material on this stuff on my website. My Twitter tag and my email address. If you have any questions afterwards, send me an email and I'll try to answer it. I've written some books, but you won't be able to read them because they're in Dutch. So nobody can read them anyway. So this is a book I wrote in 2003 on UML. I'll do this really quickly because I have way too much material to do in 40 minutes. This is my latest Agile book. It's also there in German. It's only twice as thick because they only use very long words, right? And there's an English edition as well. And that has 2 additional chapters, and that is still not as thick as the German one. So anyway, basically, I'll try to explain to you what I do is I'm a programmer. I write code. Just to give you an example of that, I was working for a Dutch social security agency, and they have huge COBOL installations. And they asked us, could you build some web applications on top of that? And I said, sure, why not? And they said, well, it has to function like it is a character-based interface. So people could not leave the page they were editing data on. They could not close the browser, stuff like that. So I was trying out some stuff to make that happen. And at that point in time, the project manager came to me and he said, could we do a demo at the CEO of the client? I said, well, I think you can, but there's some untested code in there. And I was working on some JavaScript to figure out if I could do that and pop up some alerts. And then after an hour, he got me back this screen grab. And he was like, do you have any more? For those in the back, if you can't read it, download the slide deck and you'll be able to read it. It's not very nice language. This is the code I write, right? This is my code. So basically, I have to talk about monolithical applications. Now, monolithical applications are not necessarily bad. People sort of address it, oh, those are bad because they are unmaintainable. They can be unmaintainable. One of my clients, a small company, they have a 3.5 million lines of code Visual Basic application. So that's per definition unmaintainable. Anyway, so the thing is with this code, it had an architecture once, 20 years ago, and from that point of time on, people have worked on that application. More and more people have worked on it. Different people have worked on it who have different programming styles, use different techniques. Did never hear of the fact that there was an architecture originally in the code, and then suddenly your code becomes unmaintainable. There's of course no automated tests. Because we all love writing automated tests, right? We love unit testing, do we? You should actually. So I'm sounding like a university professor now. You should do unit testing, yes. And, well, you should. So basically, large applications that have lived for a long time can become unmaintainable. And there's only one reason for that, is that they grow over time. And it's a bit like this, right? This is you know this? Do you have that in Italy? It's a Czech animation series, and it's really brilliant, actually. Those are 2 neighbors, and they always try to solve an issue just as we developers do. So they try to build something, and then they figure out, oh, we can add another feature to it, we can use stuff from something else, and they build on top of it, and at the end of every show, it breaks down, of course. Now, that is typically what we have in software development as well, right? If you have worked on code bases that have been around for at least a decade, you know that it is hard to refactor those. That's one of my favorite things to do, except for writing frameworks, of course, because we all love writing frameworks, but refactoring existing code is the best thing next to writing frameworks, what you can do, right? And the problem with it is always the same. It's dependencies. There's always dependencies in your code on stuff that you don't know how to work with. And the larger an application becomes, the longer it lives, the more dependencies you have. This picture, for instance, is a picture of a systems landscape of one of my previous clients. And actually, so this is not a single application. This is a whole bunch of applications. And they all work together. Every business process that they implement takes you at least to 10 to 12 of these business processes, of our applications. So that is really tough. They try to release stuff every 3 months. Of those 3 months, they spent 6 to 7 weeks testing all of the integration on these systems. Just to give you an example on how big this thing is, this is about 40 systems, and this is just their customer service department. No, it's actually true. So this little system here, this little pink system, it's called SAP CRM. If you ever get near to it, run away. The size, just to give you an example of the size of this thing, the database underneath this thing has 142,000 tables. Not records, tables, right? So this is what will kill you. So I'm an old guy, you've noticed that, almost losing my voice. So I'll give you a history of where I come from, just to see where microservices fall into perspective. But I'll try to do it short. So I started programming for money in 1988. Some of you might not even have been born by then, but I was programming for money. That means I've been programming for fun for 5 years more, right? Because you have to, well, anyway, so this is client-server. In the client-server era, we built software that ran on your computer, on your PC. I was doing a talk at a university last week in Belgium, and I had to explain what a PC was. It's like, I said, well, it's like a laptop, but on the side and then much wider. So every new version that we build of this software, we had to go with a floppy disk. It's sort of a USB stick, but then flat and square. And we had to run to all these PCs and install the next version, right? So and the code became creepy very fast because we didn't have a clue back then about software architecture. Well, I didn't at least. And then we moved into the 90s of the previous centuries. And we started to discover that large companies, because I worked for large companies, have large systems. And these systems need to integrate. Right? It was all about enterprise application integration or some other order of these words, but something like that. And we came up with technologies like object request brokers. And it was an architecture called Corba. And you could adhere to that and you could implement that. That was really, really tough because we wanted to get whole systems to work together. Those systems were meant to work together. So this was really tough connecting it, so it failed. Right? It was way too complex. And then we moved into this century and we started doing SOA. Right? You're all familiar with that, I hope. And so we took all these enterprise service buses and we put them in the middle, heavy buses, and like SAP buses and well, some other vendors that have stands here. So I should be really careful, I guess. But and we tried to hook that stuff all up together. So the interfaces became much clearer. So we had stuff like SOAP, and it went over HTTP, and you could do other protocols as well, but it sort of worked. Still, the things that we tried to connect were big. They were smaller than these large COBOL systems that we tried to integrate before, but still they were quite big. So you see sort of a tendency to move from, let's say, from big to smaller to even smaller. So now we've come to the era where we say, instead of writing spaghetti code, which you should be good at here in Italy, and we did it in the 90s, right? We don't do that anymore. And then we started layering. We did sort of lasagna programming. And then we sort of sliced it up into pieces. And now we're sort of here. So every small piece of code, every service or a small component, if you want to call it like that, and then they sort of work together, right? And then we have, all of a sudden, we have a system. Well, this is actually way more complicated than you think, to be quite honest. It's sort of like this, right? It's mac and cheese, and so to keep in Italian food. And for us old guys, this sounds, the whole thing about microservices, a lot of people I know, older guys, I know a lot of older guys, and they're all like this, oh, this is Groundhog Day, right? For those of you who've never seen the movie, go see it tomorrow, and then see it again the day after tomorrow, the day after. And it's a bit, oh, it's still the same, right? We're just doing the same. No, we're not. We are doing the same, and we're using a lot of the same principles, but there's some differences too. For instance, the reason why we do it. SOA and component-based development were largely meant to have large systems work together. Nowadays, we look at replaceability. So we want to replace a microservice by the next version without touching the rest of the landscape, right? Without having to touch all these dependencies. Or we want to be able to scale up. Scalability is becoming a much bigger issue than it ever was, right? So we have to do things slightly differently. So I'm going to take you through the hype. So I was at a conference in Vilnius 3 years ago last week actually, and I heard a talk by a guy called Fred George, and Fred George was talking about splitting up his code into very small pieces. At that point in time, I was looking at it, I was thinking like, hey, that's a brilliant idea. It didn't have a name back then, right? 3 years ago. So it got a name slightly after that. I'm not sure who named it, but we went on to do microservices. And then you see that the first literature came out, the first blog posts, and people were saying, yeah, we're going to decompose applications for deployability and scalability. This will solve all our problems. So people usually start writing about, right? And then they say like, so to put it nicely, what is a microservice actually, right? And then people start writing like, oh, you know what? It is at most 5,000 lines of code exposed via JSON over HTTP and then 5 endpoints, which is a very abstract way of defining it, right? And then important people started writing about it. So the ThoughtWorks people have written a lot about microservices, including Martin Fowler, and I'll get to his definition next. And then the first book came out. Look at the date, right? This is the first book on microservices. It came out in May 2014. So hence the 30 months, right? This is when I was already doing it, by the way. So, and Sam is also from ThoughtWorks. Well, he isn't anymore, but he used to work there. And then the first microservices conferences came out in November 2014. This thing was sold out in 2 weeks. You should be jealous of that if you're a conference organizer, right? And then people started doing master classes about it. It says masterclass, see? It also says microservices architecture. It's cool, right? And my name is in Moscow, and my name is somewhere down here, and people who know this Cyrillic characters, they said, hey, they misspelled your name. I didn't know, I couldn't read it actually, but that's fun stuff, right? So we're in the middle. You know this diagram, right? If you're not, get aware of this. This is the most brilliant diagram we have in this field. It's called the Gartner hype cycle. Every technology goes through this cycle, right? So it gets popular by people posting on it, people writing on it, not doing it yet. And then all of a sudden, this new technology, of which you still have to find out quite a lot, people are starting to try it out. Those are the early adapters, right? Early adopters. And then all of a sudden, it appears to be much more complex than you think. It's the same with microservices. Microservices is somewhere here now, right? People are starting to do it, and they figure out, hey, this is more complicated than I thought it was. RESTful APIs are not as simple as you think. How do we deal with transactions? These are distributed systems, right? Stuff like that. So people say, this sucks. And then they hop onto the next thing. So we're going to do reactive programming. I was in the talk before, it was about reactive programming. We're going to do continuous delivery or DevOps or whatever you can spend your time with. But in the end, if you go through with it, we'll end up here, right? And we'll see where it's good for. Now the company I worked for, an insurance company, they were like here, right? We were the early adopters. They used to be laggards, right? They were still on SVN as a service, as a version control system. And we had to drag them into Git and other stuff as well. So they suddenly moved here, which was really strange, but they needed to do this, right? There was no choice. So why would you do this? Now, let me give you a definition first, right? Definitions are important. So I'll give you Martin Fowler's definition, which is a very short definition, as he says. In short, Yeah, don't try to read this. I'll read it for you. Basically, what he says, this is an architectural style. You can debate about what is an architectural style or not, but I think if you start doing this, the way you start thinking about writing code and the way you start thinking about designing and breaking up stuff into smaller pieces, it is becoming differently. We are doing stuff different than we did before. Of course, everybody with every new paradigm is saying that, but it is true, actually. I started thinking about writing code differently, and I've been doing this for 30 years, right? And then he says, we develop a single application. It could also be a set of applications or a landscape. It depends on what you call an application. As a suite of small services, of which nobody knows how small they are, which is not really in the definition, but it sounds nice. And they're all running in their own process, which basically means that you can spin up, and they have to be stateless for doing that, right? You can spin up as many as you want, because they're all running in their own threads. And that is a nice thing, because you can make it scalable. Of course, you have to deal with discovery of services and where are these things located anyway, which address are they, stuff like that. So it's not as easy as it sounds, but you can do that. They're all communicating with lightweight mechanisms, often an HTTP resource API. That's cool, right? We can do REST, we can do JSON, and we can do RESTful APIs, and there's no contracts anymore. We're rid of SOAP. Nobody does SOAP in this field, right? It's nice, but it's structured and it's in contracts, and we want the freedom, right? Where freedom comes with responsibilities. That means you have to deal with, if you're sending out JSON, that means the ones who have to read it will have to be able to deserialize it and work with it and send it back and stuff. So it is not as easy as, well, I've said that before. I'm not going to say that. So these services are built around business capabilities. Now that is the most important part in this definition, I think. I do care for being them independently deployable and stuff like that, but building them around business capabilities, to me, is the core of this definition, but I'll get to that. And they're independently deployable, yeah, that means if you have a landscape built of microservices, let's say you have 120, like one of my clients now have. They have 120 different services. They are able, after a long struggle, to write some code in one of these services, run it through the build pipeline, and put it into production automatically. Now, as a not too big insurance company in the Netherlands, that's quite an achievement, I would say. And that is the thing, right? You can deploy individual parts without having to recompile everything that's also in the landscape. And there is a big difference. There's a bare minimum of centralized management of these services. That is the part where we'll see the most shift, I would say, on microservices. We started building them as landscapes of cupcakes. But there's stuff that we need to take care of, like how do we deal with the fact that if we run if we call on 5 services one after another, and the third one fails, what do we do with it? Traditionally, you would say, oh, we have a SQL database and we could roll back the transaction. There are no transactions here. How do you deal with that? So you have to find different techniques. That means sometimes you have to think about messaging. You have to think maybe about a message bus or doing event-driven architecture or setting up queues. So there's additional stuff to do here. And they can be written in different programming languages, which is good, because if I look at the audience, there's probably people experienced in maybe 10 to 12 different programming languages, right? I don't know, I'm not going to ask, but I don't suppose you're all doing Java, right? You've probably all learned to write Java. Does anybody still write COBOL? You do? Oh, that's awesome. You will have work for the rest of your life, dude. You have to support single-handedly 220 billion lines of code in production, right? That's 80% of everything that is in production, by the way. So if you want to make money, learn COBOL. So yes, you can write it in different programming languages because they communicate over HTTP, right? That makes it easy to work in different programming languages. It also means you have to support all these different programming languages. And if you are a company that has like 30 Java developers, you better make sure you're not going to do whatever, Go or C# or whatever you want, because you're not experienced in that. So if you split up everything into teams that have like 3 people in there, if 2 leave, you have an issue, right? You cannot support that code anymore. So yes, different programming language is possible, is really good, not for all companies. And the last thing is, you can use different data storage technologies, which is really a cool thing. One of the guidelines we set out when we started doing this is we said every component has its own database. or its own storage, right? So some store to the file system, some store to a relational database. Well, we got rid of them anyway, but and we use for unstructured data, we use document databases like MongoDB. I love Mongo, by the way. Or you could do key value pair database like Cassandra or whatever you want to do. As long as you say, every component can have its own database. And that is a cool guideline, actually. So that's the definition. And then you see a lot of people talking different things. There's basically two aspects to what you're gonna, if you look at strategies on implementing a new code. So either you're coming from a brownfield situation or you're coming into a greenfield situation. Greenfield means we're going to get rid of all the code and start all over again. That sounds really nice, but it also means that you have to do a lot more than if you come out of a brownfield situation where, given a large code base, you can split up small things. You can pull out small parts of it. That is the difference between green and brownfield. A lot of people have different opinions on it. First of all, ThoughtWorks says, we are certain that microservices are the future direction for software architectures. So we're going there, if you want it or not. That's basically the way of the web, right? And then Simon Brown, he says, well, if you're unable to build a monolith, what makes you think microservices are the answer? So if you're not good at maintaining monolithic code, if you don't know shit about architecture, you better make sure that microservices are a bit more complicated than that. So, and the next one, so Sam Newman says, brownfield is easier. Duh. Because you already have a lot of the code, and you can pull parts out and make them independent of the rest of the code and just rewire everything to those new parts. So that is easier than greenfield. Martin Fowler agrees with that. And then Stefan Tilkov, who's German, he says, don't start with the monolith when your goal is a microservices architecture. Germans, right? And he didn't use very long words, though. Anyway, it looks rather English for German. But so basically what he says is, if you're starting to write new code now, don't write monolithic applications. And I agree with that too. So basically, oh, by the way, if you're going to do this, you have to be aware of the fact that you are building distributed systems. And distributed systems, building those is really, really hard. Because, again, transactions, stuff like that. To convince older people who are used to having relational databases, the first question they say is, how are you going to deal with transactions? And then you say, oh, we're just going to avoid them. And they're like, that's not convincing enough. So it is hard. And again, Martin Fowler, his famous first law of distributed objects, do not distribute your objects. Right? Deal with that. Anyway, so the question is this stuff now our new stairway to heaven, or is this our next highway to hell? So basically, those are my musical preferences. So let's get on with it. So I started working for this insurance company. They made me meet their CTO. I guess they were really tired, but well, somebody has to solve the issues, right? And so I tried doing that. This is where they came from. They had a mainframe. They still have it, by the way. Running the mainframe alone, the total cost of ownership of this thing is around €1 million a year, right? It's sitting in the basement. It's just humming all the time, and it's a nice machine, really big. It costs a lot of power. It's not really green, right? And there's COBOL code on it. 18 million lines of COBOL code. And they have, the largest Java application they had when I came there was like 12 million lines of code. And they wanted to get rid of everything. Basically, they had to get rid of the COBOL code, which looks a bit like this. This is actually not really COBOL, it's ideal, but it's sort of COBOL. This is what they write. Do you know what they use for IDEs? None. They just, have you ever seen this? Well, you've seen this, right? They just move up and down the cursor on left and right, change some characters, save the stuff, that's it. I don't know how these guys program. Anyway, the problem is, the programs they have for that, they are aging. And they will retire within the next 5 years. That means if you have 18 million lines of code, either you hire him or them, or you have to get rid of it, right? And then you could outsource it, of course. Basically the same problem. So the next step was, remember this is an old insurance company, right? And the next step was that they had to rewrite everything in Java. So now they're stuck with these guys. If you go to a Java conference, it's mandatory to have a beard and glasses. So on average, you're good. And they were like, "Ooh, this is scary stuff, right?" They didn't know what to do. So we moved on. That's a bit like this. You know, this is the end of Finding Nemo, right? Where they have escaped from the fish tank, but in plastic bags, and jump into the sea, and they're like, okay, now what? That's the point where most of the customers are that I meet, right? They're like, we're totally stuck. Either we cannot maintain our 3.5 million lines of VB code, or we have this COBOL shit that we want to get rid of. Or my new client who has COBOL in the backend that is compiling to Java. They do write Java as well. They write C#, because they have to work with Exchange servers and stuff like that. And then they have a system in PHP. And they are moving to microservices and continuous delivery, and they're doing Agile. All at the same time, right? So those kinds of issues. Now, and then I said, you know what? And I say that to all my customers is, you have to realize this is very young technology. It is good technology for a lot of aspects that we have, but it is really young. So you have to allow yourself to learn. So to organizations that do not allow themselves to learn, I usually say, don't do this. Because there is a lot to discover, right? And that's a good thing if you like doing that. But if you don't like it, it's weird. So the question is, what did we learn? By the way, this is the product owner of my teams. Anyway, I don't know why I say that. So the thing is, you have to allow yourself to have an evolutionary architecture. That does sound really difficult. It isn't actually. The thing is, you have to figure out where you're going and why you're going there. So as an example, I'll give you the guiding principles, because that's the way to start, right, of the company, the insurance company I worked for. And they're a bit like this. Well, basically the client says, oh, we always do business processes, so you better implement business processes. And we say, okay. And then we say, well, we have to move away from the mainframe. We stop writing requirements. That means we don't stop writing them, but we stop writing them in Word. So we moved on to a modeling tool, because this is a complex landscape, right? You cannot maintain the documentation of a complex landscape in a Word document. Very simple guideline. And then we said, you know what? Applications, and we're making very simple applications, very small ones. So we don't build this next really big web application, what they wanted to do first, but we have very tiny web applications that only implement a single business process. And these applications, they don't have data storage. So they're just front-end technology, any front-end technology you might want to use, and they're connecting into small components that deliver services. Now these components, we allow them to talk to each other over HTTP and have their own data storage technologies. So we slowly moved away from DB2. You've probably never heard of it. It's a database. It's a relational database. You might have never heard of relational databases. Could be, but anyway. So we moved it out, and we moved Mongo in component by component by component. Saved a lot of money, by the way. And that's basically what we said. We said, you know, we're going to avoid transactions. Didn't solve anything, but it sounded nice, right? This actually comes from the original presentation that I did at this particular client. And we had two very tiny architecture pictures. These are the only architectural pictures we had. It's just these applications had 4 layers, some UI technology, some use cases, some domain, and it all resolves around the domain, of course, and some code to get out to our components and our services. And the components have a similar architecture. And it's just this picture with the patterns in it. There isn't much more to it. They basically have a service interface. Also, they implement services as use cases, so we could model them in use cases. It sounded handy at the time. It still is, by the way. And they also have their own little domain, their own bounded context, and some code to get out to the database. Now, the funny thing about having architectures like this is that in the meantime, they have built around 120 of these small applications and components. And what they discovered is, or what we discovered is that although the way we programmed it changed a lot, we moved from very traditional Java programming to very functional Java programming using different frameworks. So the first component we built, the first service we built, has very different code than the last ones we built, and we're still building them. Or they're still building them because I left, but they still have the same architecture. So they have the same patterns that we implemented, the same layers that we used. So you can recognize, if you open up any of these repositories, you can actually recognize the code still. And my hope is that they will continue to do that, even after I've left, to maintain this architecture. So in 10 years' time, they still will be able to read the code. Now they have the big benefit, because if these components are really small, well, less code is always easier to read, right? Well, not necessarily, but usually. So the big question is, how do you split up, how do you do the design of these small components and these services? And the answer actually came from my normal knowledge about software engineering. So I hadn't even had to learn something new. I was still okay. Because this is what happened. I'm going to skip this one. So we looked at, for instance, the solid principles. And we took out the single responsibility principle. We said, you know what? We group together things that change together. And that's not the data, that is the code, right? So if there's a piece of code here that is changing, and to be able to change it, I have to change some code here, you might as well put those together in the same component. And the same goes for things that do not change together, right? Separate things that change for different reasons. We had a component that had the insurance product definitions in it, and it used standard text all over the code. And after a while, we figured out that those standard text, we could also use them from very different angles of the applications that we were writing. So we split it out. It became a very small component. It probably has like, I don't know, 100 lines of code. That's about it. And it is useful because it's changing in a different direction now than the product definition component does. So that's one of the sort of things that we kept in the back of our heads to do this stuff. The other one is called the bounded context. Now, if you've never heard of domain-driven design, read the book this weekend, right? It's not nice literature to read, but this is the good book on how to do domain-driven design. And domain-driven design is at the heart of every single component that we do. Now, the bounded context pattern, when I first read about it in probably 96 or 97, I didn't really understand it because everybody was still creating this huge, single, big, unified data model or domain model. So what was this bounded context about? Well, I'll explain to you. But I only have like 8 minutes, so I'm going really, really fast for the rest of the 200 slides I have. So anyway, so this is my big unified data or domain model, whatever you might have. The thing with this model is it actually has two parts. But because you're building a unified model, that means the product class in the middle, so this is basically ordering, and this is basically refurbishment, so getting your inventory up. So the product class in the middle has different responsibilities on both sides. It has the responsibilities when it comes to reordering stock, and it has the responsibilities as it comes to ordering, right? Now the thing is, if you build this unified model, if you want to change something in the ordering part of the system, you're dragging along the rest of the system. Now if your model is full of all these things, that means you're dragging it along in all sorts of directions, but the dependencies are still there. So the bounded context pattern says you could split this up into two different parts. So now I have a sort of an inventory component and I have a stock component. Now if you use this pattern, if you look at these big models that you might have, you can easily recognize those classes because they're usually somewhere in the middle with all sorts of lines to it, and then the lines on the other end go to another, like it's sort of a star architecture, you could say. Those classes probably have too many responsibilities. And then you go back to the single responsibility principle and you say, okay, this thing can only have one responsibility. It cannot be in stock and inventory at the same time, or orders at the same time. So split it up. And usually classes have more than two responsibilities. It's slightly tougher than you might imagine. And the only thing is, the only connection between the two is a very thin line where you probably have the ID on one side into the class on the other side, which is not that hard. It is not like a foreign key relationship because this becomes two very different things. The code bases of those two parts can grow in different directions. Now that is the ultimate thing in splitting up your code into smaller parts, into microservices. So as to the size of a microservice, I don't care how many lines of code there are, how many endpoints it has. They usually resolve around a single resource, a single collection, which is basically the aggregate root. If you look at domain-driven design, which is probably product or order in this one. And that is the way you can have your small components evolve. So size is not really important to number of lines of code, but to is it a bounded context? Does it deliver a single business capability, according to Fowler's definition? So that's the thing. So here's an example of that. This is a domain model of one of the components of one of my clients. It isn't any bigger than this. That means all the code you write around it, so all the validations, all the endpoints and stuff like that, and putting it in a database and back, is really small, is easy to maintain. So that's good stuff, right? Now the next point, and I'm going to make like 4 more points before, before they drag me off stage, is about REST. You all know about REST, right? You all know the right status code to the right messages and stuff. Well, I didn't when we started doing this, and I tried to figure out. And as I realized, there is no standard to this stuff. There is no standard set of rules that says if you are defining a RESTful API, you have to do it like this. And that's not necessarily a bad thing that there is no standard, but if you have 6 teams working on your software, you better, or more, like maybe 150 or so, you better make sure that you agree on how these things are set up. And you have to look at stupid stuff like, oh, if I have this URL, or URI, it says 42 at the end. Of course it says 42. So what is it? Is this the idea? Well, what is this then? Oh, it's an ISO code, so I might have to put it like this. Or maybe I should put it as a query parameter. These two sort of give the same results. Well, they don't, because they have different status code. And a number of them gives back a collection of JSON objects, and a number of them gives back a JSON object, a single one. So how do you deal with this? So I'm not being able to solve this stuff for you in 5 minutes, but there is no standard. So you have to agree, and you have to talk to the other teams. You actually have to talk to people, right, while writing code. You do, to make sure that you all do it in the same way. You can set up your own guidelines. But basically, here's my guidelines for status codes. This is basically sums up everything you can do with HTTP status codes. Just that's an easy one. Remember this one. And then there's Postal Slow, right? There's a guy called Postal. He looks like a Java developer. Anyway, but he says, be conservative in what you send. Be liberal in what you accept. That means, as a service, try to send out as little as possible that actually satisfies the needs of your consumers. And as a consumer, you have to be aware of the fact that you might not get back from a service exactly what you need. For instance, if my service passes back an account object and it has 3 properties and I expect 6, I have to deal with the other 3, right? I have to fill them in myself maybe, while deserializing and adding stuff to it. Or maybe they have more properties than you expect. So you might thinking about, oh, it could crash now while deserializing, but I might also try to ignore the other ones. So that's basically summed up in Postal Slow. Be aware of the fact that there are no contracts between components and consumers. So that means if you send out JSON, somebody else might be expecting something else. That is also the reason that while building microservices, you have to test very rigorously. Because every change in your API, every field that you add into a JSON object, or every field that you remove, which is even worse, you have to take care of that. So testing becomes really, really important. And the thing is, and I don't hope there's any testers in the room. There usually aren't, because they never had time to go to conferences, right? Testers are always behind. Not because they're stupid. No, not because they're stupid, but basically because they have too much work already. So that means if on a microservices project or program or whatever you might call it, one of the reasons to do that is because we want to deploy independently, right? And we want to be able to do stuff like continuous delivery. Like my client, my product owner thinks of something now that, oh, -5? Does that mean I still have 5 or I'm 5 minutes overtime?
Okay, 5 minutes.
Okay. Sorry, guys. You're missing out on coffee. Which is not a good thing, in Italy especially. So basically, if you want to move fast, that means you want to be able to deliver the stuff you think of right now, today. You want to have that in production by the next day, or at the same day, in a complex field of 120 services or more. You cannot test by hand anymore. That period is over, right? Testers will become developers as well. Because what you want to do is you want to fail as fast as possible. That means if I write my code now, I'm running my unit test, they fail, that means I suck at programming, I redo it, I check the code in, and then the next step is that it gets tested automatically. So we created a sort of a series of events that take place, right? We say, you know what, is there some other stuff to it? Yeah. We say, you know, well, we're first going to do the design. That's basically in the morning, right? 9:15 or something, or whenever people get up. And then we write some code, and we write the unit test, and we run them. The next thing we do is we check in the code, and we go to a colleague, and we say, could you please look at my code? And make sure that the unit test also run on your machine instead only on my machine, right? That is sometimes hard, by the way. And when he says, it's okay, the code looks good, we have looked to our guidelines and we can check in this code, then it goes in again into the repository, the build goes off, everything gets compiled, the unit tests run again on the server, and then Sonar runs, for instance, in our company, and then it is deployed to the next environment, which is virtual, by the way, and then we test all the components interfaces automatically. So there's code at testing all of the APIs on our components. And after that, it's deployed into another virtual environment that does the integration tests. But they are much more expensive, right? Because that is where you run through all your web scenarios and your mobile scenarios, and those are expensive. They're expensive to write and expensive to run. So that means you have to do them slightly later on, right? So this is basically the strategy when it comes to testing. And all this, this is probably a very smart tester, I don't know. This testing by hand is really, really gone. I'm not allowed to talk at test conferences because of this sentence, right? So I have to talk to the developers to do this. And stuff like user acceptance testing, it's gone as well. Because the changes are so small that you cannot set up a user acceptance environment or whatever it is to just test whether this button has moved from left to right, or small changes to the environment, right? So you have to let go of everything user acceptance testing, which is good because they're a pain in the ass anyway. And so, last step, about deploying this stuff. The problem is you have to set up your pipelines. Now, you've probably all have done this. I hate this. I'm not really good at this stuff, right? So I have other people on my team to do that. The thing is, if you do microservices, we have a repository per component. So we have 120 repositories. 120 repositories, but this is an example of a pipeline, but 120 repositories means I have 120 pipelines, right? I have many of those. Now, if I want to add a step to one of these pipelines, I probably want to add it to all of the pipelines, which basically means I have to open up all 120 of them and add the step into it. That didn't seem really nice. So we figured out that we had to figure out a tool that actually did this for us. Now the problem was we started off with Jenkins, and then we did Bamboo and TeamCity and GoCD, and then we moved back to Jenkins because we couldn't find it. So we had to build it ourselves. Now that is not necessarily a bad thing, and the problem only is that the people who usually do those things are the IT professionals in the company. Now the IT professionals in the company I work for, they can handle Windows, more or less. They can handle this Microsoft Office, more or less, but they haven't got a clue how to do this stuff. So we hired experts to do that. And later on we figured out that wasn't a good idea, basically, but I'll show you. So some of the tools, I'll skip some of the tools, basically. This is Sonar. Go use Sonar. Sonar is a very nice tool, or some other static code analysis tool, because it helps you increase the quality of your code fast. And then we used Jenkins. We moved back to Jenkins, good old Jenkins, and we used the enterprise version, because we had to pay money for something somewhere. The rest of it was all open source, right? So we had to figure out a way to get licenses somewhere. That's the IT professionals talking, by the way. They really said this. It's not a joke. So we put up nice plugins. Do you know the leaderboard plugin? That is a really cool plugin. Check it out. I'm on seconds here. That means I did a lot of check-ins without breaking the build and adding a lot of new unit tests. So you get 1 point for that. You get -10 if you break the build. So if you're here, you probably have broken the build. This is a tester, by the way. Anyway, so we use GitLab. GitHub is good enough. Bitbucket too. We use GitLab. We like the tools because they give nice graphs, right? These are all the check-ins over time of one of our components. See, this is me. I had the most ones. So it's probably good code. Anyway, so we use tools like this. The problem was that we got is that the experts came in to arrange this stuff. And the problem is they think differently. They're not developers, right? They're not coders. They do know how to do a bit of groovy and stuff like that, but they haven't got a clue. So in the end, after a while, oh, they did do nice things. We had to rearrange everything again. And I got the most lazy developer on the team to do this. You know why? I'm lazy as well, by the way. You know what lazy developers do? Every time they see something that they have to do something, and I do it a second time, and they're like, I don't like to do this. And they do it a third time, and they're like, oh, this is crap. I'm going to build something for this. So we got the most lazy developer on my team to build stuff like this. We built a board that got an overview of all of our components on the nightly build. So we checked we check this board every morning, and if everything's green, we can go into production. And he just built this combining data from Jira and Jenkins, and we did some Angular with this. Of course, we had to do some Angular anywhere. So, and then he built the next thing that said, basically, in this version of the customer component, we just added these features. So these are Jira numbers, issue numbers, and these ones broke, so it's broken now, and these ones do work. So we're sort of creating a sort of visual representation of our landscape, and you have to do that because these landscapes get really, really complicated. So anyway, I'm trying to break this stuff up, although I could talk about this all day, definitely. The thing is about microservices, as I try to explain during these sort of 40 minutes, or maybe there are 50 already, I don't know. I'm afraid to ask. And so be aware of the fact that there isn't such a thing as, oh, we're going to do microservices, done. You have to figure out a whole lot of this stuff yourselves. You have to think about transactions, about pipelines, about design, about bounded context, about RESTful APIs, and a whole bunch of other stuff, about programming languages, moving to different databases maybe. So there's lots of stuff to take into account. So you have to figure out for yourselves if microservices are the direction for you. If you have a monolithic application that you can still maintain, there might not be a reason to move here. But if you have issues with scalability or replaceability of the parts of your system, then this might be the case for you. So all this stuff you can use from this basic large paradigm of stuff that goes into this, including stuff like continuous delivery and DevOps. It all hangs together. This is basically, if you do Agile, the best architecture to do Agile. Also, what Eric Evans says, he says this is the best architecture to do domain-driven design. So those are good recommendations, I would say. But it's not very easy to do this. It's a hockey stick model. I didn't know what this was. Sam Newman said this to me in a bar somewhere, I think in Kiev or so. He said, well, it's a hockey stick model. I said, what do you mean? He said, well, basically, you take a whole lot of time to set everything up, to make sure it runs. And after you got all the tooling in place, and all the ways you want to write code that changes, after that, you can go really, 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 really fast. And that is true if you allow your teams to learn. And if you decide to have fun. But we're in the best field in the world. Right? There's no business like writing code. That is the best you can do in the world. So, I'm done. Here's my contact data if you have any additional questions or remarks, my Twitter tag, my email address, and have a very good afternoon.